Positively Perfect Problem Solving presents Solving Multi-Step Equations. So far, we've been solving equations that only have one solution. And I'm going to explain what I mean by this. So an equation that has one solution has only one value that works to make the equation true. So only one value works to make the equation true. Now, you guys know this already, even if you've never really talked about it this way. And I'll show you what I mean in this example. So if I were to give you this problem, most of you would draw your line through the equal sign and you'd start solving for x. You'd subtract 1 on both sides. You'd get that 2x equals 6. You would divide both sides by 2. And you'd get x equals 3. Now, the real question is, do you guys know what this means? And I think this is really important, right? When x equals 3, this means that if I plug 3 into this equation, it will make it true. So I'm going to go ahead and show that here with this wonky arrow. So if I plug in 3, and I'll use a different color here. So if I take this 3 and I plug it in, so I'm going to rewrite this equation so it says 2, but instead of x plus 1 equals 7, I'm going to replace that x with this 3 that I just found. And now what happens is that when I go ahead and start simplifying, 2 times 3 is 6, bring everything else down, and then I get this thing that says 7 equals 7. That 7 equals 7 means that that 3 is the only value that when I plug in for x will make this equation true. If I plug in something else, you don't have to write this down. If I plug in 4 and I try and do the same thing, I'll get 8 plus 1 equals 7, and I'll get 9 equals 7. This is not true, so 4 doesn't work. Only 3 works in this equation. So most of the equations you've solved have one solution. However, sometimes equations have no solution. And this means that there's actually no solutions that make the equation true. No numbers that if I plug in will work. So let's take a look at what that might look like when you're solving, because it looks a little bit interesting. Let's go ahead and draw our line like we would normally, pretending this is a regular equation. I'm not going to pretend. This is how you would go about this. And let's go ahead and solve this. So I'm going to distribute this 5, get 5x minus 20 equals 5x minus 27. And now, like normal, I'm going to try and get all the variables on one side and all the numbers on the other. So I'm going to go ahead and add 20 over and add the 20 over. These cancel out, the 5x comes down, and then I get 5x minus 7. Now I have to get all the x's over, so now I have to subtract 5x on both sides. And now here's where things get a little strange. When I look on the right side, I obviously know those canceled out because I was trying to get rid of it. The left side looks identical. Notice that it still says 5x minus 5x, and I know you'll be tempted to do this. Don't write this down. Don't do this. If you've got two things that subtract from each other and cancel each other out, don't write down 0. Just cross them out. Okay? We can put the 0 down, but what I don't want you to do is I don't want you to do this with the 0x. Okay? I just want you, when you cancel something out and there's nothing left, see how this left side is empty? That's when you write the 0 as a placeholder. On the right side, we've got that negative 7. Now this thing we've created looks very strange. It says 0 equals negative 7. You have to ask yourself, is that true? Does 0 equal negative 7? And that's the question I want you to think about. Does 0 equal negative 7? If the answer is no, then that means that the answer to this problem is no solutions. So instead of boxing this, what I boxed, instead what I want you to put a box around is this answer of no solutions. Okay? That's what that means. If you get two things at the end of your problem that don't equal each other, then that means that nothing will ever equal each other. There's nothing we can plug in that will work. Okay? The last option we have is if we have infinite solutions. Infinite solutions is pretty cool. Infinite solutions means that any value, no matter what we pick, it will make the equation true. Let's see what this looks like in a complicated equation. So here's my equation. I'm not quite sure why it's so far to the right. I don't know why that happened, but it did. I don't know why we have all this blank space over here, but it is what it is. Okay, so you're going to draw your line like normal. We're going to go ahead and solve this. Now, don't forget this really important part. Some of you are forgetting this when I'm noticing your practice and your mastery. You've got this little invisible -1. So when you go to deal with those parentheses, you actually have to distribute that -1. So I'm going to get 6x, -1 times 1 is -1, and -1 times 5x is -5x, equals, bring down the x minus 1. And now I'm going to combine like terms on this side. I notice that -5x and 6x are like terms. So when I combine them, I end up getting 6x minus 5x gives me 1x. Bring down that, I cancel these out, they're gone. Minus 1 equals x minus 1. Now here's something you really need to notice. Do you notice that, and I'll underline this here. Do you see how x minus 1 is the same on both sides? I've got x minus 1 equals x minus 1. That's really, really important. If it's the same on both sides, then it doesn't matter what I plug in. And I'll rewrite it over here. If I have x minus 1 equals x minus 1, and I replace this x with 2 and get 2 minus 1 equals 2 minus 1, that will work, right? If I replace it with a 4, does 4 minus 1 equal 4 minus 1? Yeah, they both equal 3. So this type of equation, when you get a solution where you get the same thing on both sides, that means that has infinite solutions. So your actual answer you're going to write on your paper when you get to something like this is you're going to write all real numbers. That's how we describe infinite solutions. No matter what, any number will work. Okay, so as we're doing practice in this learning target, no matter what kind of equation you have, and this goes for the test as well, you might come across equations that have no solutions and infinite solutions. So just be on the lookout for those now that I've shown you these three things. The next thing in this learning target we're going to talk about is equations with fractions. And this concept can be extremely difficult. In fact, I didn't teach this last year to pre-algebra, but I think this year I'm going to try and make a go of it. It's something that you're going to see in Algebra 2, and I really think all of you can get to that class. So I'm going to show you what this is, and it might take you a couple days to get the hang of it. So the major concept with fractions is getting rid of a fraction. I don't like working with fractions. No one really does. So there's some tricks, like little sneaky things that mathematicians have learned to do to get rid of them. One of those sneaky tricks to get rid of a denominator is multiplying by the denominator. And I'll show you what I mean by that. If I have 5/4 and I decide to multiply it by 4 over 1, okay? And I know I taught you guys on the calculator how to do this. So I'll go ahead and show you on the calculator. You could do this by hand as well. It doesn't matter to me. But let's say we do 5 divided by 4, and then I multiply it by its denominator. I multiply it by 4 over 1. I end up getting 5, which is really cool because 5 is actually that numerator. So what ends up happening is the 4's go away and I'm left with just the 5. This is a very cool trick. The same thing will happen no matter what we do. If I multiply this guy, I'll use a different color. If I multiply him by 6, if I do 4 6 times 6, 4 divided by 6, oops, my calculator's being weird. 4 Come on, 4. There we go. 4 divided by 6. And then times 6. I'm going to end up with that 4. So in reality, these things are canceling each other out to give me 4. And the reason they cancel out, for those of you that really want to know, is that what I'm really doing is when I do 4 over 6 times 6 over 1, which is what 6 is, on the top here, I have to remember a very cool fact. If I have 6 divided by 6, that gives me a 1. You don't have to write this down. This is just for you guys to know. Any number over itself gives me 1. So in a real sense, the 6's don't just go away, they become 1. But 4 times 1 is the same thing as 4, and 4 over 1 is the same thing as 4. So this very complicated math right here is why we can use this trick. And this trick becomes really important as we see some more complicated equations, okay? Because these eliminated the denominator, right? My final answers are just 4 and 5. The denominator went away. So let's take a look at where I'm going with this. I do have a point, actually. So the next type of equation is equations with fractions, okay? And I'm going to start you off slow. So this first example is an equation with one fraction. Now this may not look like a fraction, but it is. Anything that has something on top and something on bottom of the bar, that's a fraction, no matter what. So the trick we're going to use to get rid of this 10, and it's a rule we always want to do. Remember in the last learning target I said there was a step 1 and I said we'd get to it? Well, step 1 for every equation is to get rid of your fractions. I told you guys we'd talk about in this learning target. Well, here it is. Get rid of your fractions. And to get rid of them, to do this process, you have to multiply both sides by the denominator. And I'll show you what I mean by that. So if I look at this equation right here, my denominator is 10. And I'll highlight that here. So my denominator is 10. So what I'm going to do is I'm going to multiply each side by 10. So I'm going to do this. And watch how I'm writing my work. I'm telling you, like I told you in the last learning target, if you come up to me and ask me for help and I don't see your work neat and organized, I'm going to try and work with you and make you go back and redo it. Because organized work is the only thing that will save you here. It is very complicated math we're doing. Okay? So I'm writing my times 10 here, and I'm going to go over here and write times 10 on the left. And I'm going to draw my bar. Okay? Now, like I showed you before, this 10 and this 10 will go away the same way it went away here in this previous example. This is how we get rid of it. It's a little cool little trick. But if you don't multiply the other side by 10 as well, then it will not work. It's a balance, right? If I have an equation, I have to keep both things equal to make it work. So whatever I do on one side, I have to do the other side. So because I multiplied by 10 on the right, I've also got to multiply by 10 on the left. So 10 times 1 is 10. And then on the right side, this is the strange part. On the right side, I'm left with this thing right here, which is 3 plus n. So be very careful when you write your next step that this becomes 3 plus n. Now you've got an equation that you kind of know how to work with, right? This one's easy. If I want to just keep going, I'll subtract the 3 on both sides. Those cancel out. 10 minus 3 is 7. 7 equals n, and I'm going to rewrite it so it looks pretty. And I get n equals 7. So suddenly a very complicated equation with a fraction became much more simple. Okay, and that's what we're trying to do here, is to get rid of these fractions in a simple way to help us get to an easier equation. Sometimes, however, it's a little more complicated. Like this looks terrifying. I know it looks scary. I know when you look at this, there's like negatives and fractions everywhere. Okay, but with the trick we just learned, we're going to make this so simple. It's only going to be like a 2-step problem. I promise. It's very cool. The only tricky part about this one, see how they all have a fraction? They all have this 3, the 3, and the 3. So I want to get rid of that 3 everywhere. So the trick here is that you're not just multiplying both sides by 3. You have to multiply every term by 3. Now, we had a learning target where I talked about this word term. I'm going to highlight it. Oops, or I'm just going to cross it off. did not mean to do that. Let me undo and try and get my highlighter now. We had a learning target where I told you guys how important the vocab was. This is where it comes to play. I'm saying the word term. I need you to understand what a term is. I need you to know that this whole thing is a term. I need you to know that this whole thing is another term. And I need you to know that this thing on the right is another term. Okay, this is why I had to teach you guys this, because when I say the word term, I need you to understand what all that means, including the negative. So it's the same process as before on this guy. Say we multiplied everything by 10. Well, to get rid of this denominator, we're going to have to multiply everything by 3. So I'm going to go ahead and do that. I'm going to multiply, let me use a different color. I'm going to multiply, and notice my work. I put it up here, times 3, and times 3. Then I draw my line. I'm not going to need this long of a line. You're going to see a very cool thing that happens. So just like in the trick before, this 3 and this 3 are gone. This 3 and this 3 are gone. And this 3 and this 3 are gone. And now you just write what's left over. What's left over is this negative 10 and the p. So negative 10p. What's left over here is a negative 5p. So minus 5p. Equals, the only thing left over here is a negative 5. And suddenly I've got an equation that is 10,000 times easier to work with. I can combine these like terms, negative 10p and negative 5p, to get negative 15p. And the negative 5 over here drops down. I divide both sides by negative 15 to get rid of that, to get p by itself. They cancel out, and now be careful. 5 divided by 15 is not 3. Okay, I know you think it is, but notice the 5 is on top. So when I go into my calculator to test this, and this is going to happen 10,000 times, 5 divided by 15 is actually 0.3 repeating, which if we put it in our calculator and get a fraction, is actually 1/3. So p actually is 1/3, not 3. This is extremely important, and this is what happens when students work too quickly. They see a 5 and a 15, they think 3. But if the 5 is on top and the 15 is on bottom, it's 1/3. Now you will get fractions in this learning target. Okay, so you will get fractions. I want you to be prepared for that. And you might get some weird ones. So on your practice, don't be freaked out when you get fractions. Just go check your answers and see if they match the fractions I get. Okay? Now, the last step that is tricky is what happens if my denominators are not the same. And this is the hardest part about this. So do you see I've got a 4 and an 8? Well, I can't, if I multiply everything by 4, the 4's cancel out, but that won't cancel out the 8. So we have to use a little bit of thinking, and we have to think about a common denominator. So if I look at 4 and 8, what is the common denominator between 4 and 8? The common denominator between 4 and 8, and I even put this over here as CD, the common denominator is actually 8. Okay, both 4 will multiply to 8 and 8 will multiply to 8. So 8 is the number I'm going to multiply by. So I'm going to write my work really carefully. I'm going to put a times 8, a times 8, and a times 8. I'm going to draw my line. Now here, the 8's cancel out. But what happens here? I have 8 and 4, and I can't cancel out the 8 and 4. So here's what I would do. In your calculator, do you see I've got the 5 and the 8 right next to each other? You're multiplying, right? You're multiplying by 8. So do 5 times 8. I get 40, and then see how there's a 4 underneath there? That's division. So then I'm going to hit divide by 4. So 40 divided by 4 is actually 10. So instead of this being 5m, it's going to become 10m. And then they cancel out. All of that cancels out. Okay? Use your calculator for this part. It's critical. Okay? And if you need help, I can show you how the calculator will help you. The rest is simple. Here I've got negative 2 times 8, which is negative 16m. This is a positive 10m. And on the right, I'm just left with negative 29. And now this problem just becomes like any other problem. Negative 16 and 10 gives me negative 6m. And I will get a fraction here, but that's okay. Divide both sides by negative 6. And m is going to equal positive 29 over 6 because I've got two negatives there. I can't reduce that. And I know I can't reduce it because if I go into my calculator and I type in 29 divided by 6 and I hit enter, and then I hit math, enter, enter, notice I still get 29 over 6. So sometimes you guys come up with questions and I tell you to reduce it and you're like, oh, I thought I did, or how do I do that? This is a really easy, quick way to see if you've reduced it or not. It's just to check in your calculator, okay? We've got one last problem that is the hardest problem here. And I know this seems overwhelming and I understand you're overwhelmed, but it's okay. I'm here to help you. This has got 4 different denominators. Okay, but again, we are going to try and find a common denominator. So when I look at this problem, I always look at my biggest number, which is 40. And I ask myself this question: does 4 go into 40? Yes. Does 8 go into 40? Yes. Does 2 go into 40? Yes. If my answer to all those questions is yes, then my common denominator is 40. Okay? Easy peasy. If my answer is no, okay, which I don't think I put any of that in your practice, but if the answer is no, like if I have something like, you don't write this down, but if I have something like 2/3 K plus like 1/5 K, 5 and K, 3 and 5 don't really work, but if I do 3 times 5, I can do 15. Okay, but I don't think I put any of that in your practice, but we'll see. I might have. And if that's the case, we can skip those problems because those are a little too hard. Okay, so anyway, sorry. Now that I know that 40 is my common denominator, let's use the purple again. Now I'm going to be really nice and neat. Times 40 here, times 40 here, times 40 here, and times 40 here, because there are 4 terms to work with. And I'm going to highlight them in case you can't see them. This is my first term, 159 over 40. This is my second term. This is my third term with the minus sign. And this is my fourth term. So those are my 4 terms. So now I'm going to go ahead and do my multiplication. The 40 here and the 40 here cancel out. Cool. That makes my life easy. Then I've got this 40 times a half. So see how it's 40 times 1/2? That's another way you can do this. You can actually put 40 in here times and then 1/2. That might be an easier way. Hit enter, I get 20. So now I know that this reduces to 20K and this becomes 159. Okay. The left side, and I'm going to cross all that out. The left side, now I've got 40 times 11/4. So I'm going to put 40 in my calculator times parentheses 11 divided by 4. And I end up getting 110. Do you see how the fraction goes away? So I have a negative here, so I can't forget that. So I've got a negative 110K. And then cross it off, I'm done with it. And my last multiplication is 40 times 15 over 8. So I'm going to do 40 times 15 divided by 8. I'm going to hit enter and I get 75. You should get a whole number. If you don't get a whole number, you're making a mistake. So now I know this is a minus 75. Oh, I kind of wrote that weird. Sorry, guys. Let me rewrite that. Negative 110K minus 75. There, now it lines up nice. Cool. So I've gotten rid of all my fractions. Now this is like a problem you guys have seen a million times. Get your variables on one side. Negative 110K minus 20 is negative 130K. Bring down the negative 75 and the 159. You might be working with big numbers. Don't freak out. That's okay. Oops, don't divide yet. Don't do that. Don't do that. My bad. Add the 75 over. They cancel out. You get negative 130K equals, I'm going to do that in my calculator because I can't do that in my head. So 159 plus 75 equals 234. And now when you divide by negative 130, you're going to probably get a fraction. 234 divided by 130 is going to give me 1.8, but I don't want decimals here. So I'm going to hit math, enter, enter, and I get 9/5. Now it'll be a negative because of this guy right here. So negative 9/5. This is as hard as it gets, guys. It's hard and it's time consuming, but do you see how nice and neat my work is? See how I've crossed things off and labeled things? That's what you need to do as well. Okay? Good luck on your practice. Take your time. I would say 2 days for this learning target, and please ask for help. Okay? Good luck.